Hi everyone, welcome to my channel. Today, we're diving into one of the most crucial hooks in the React library, the useEffect hook. It can seem a bit tricky, but don't worry, we'll break it down step by step. We will cover everything, from basics to advanced topics, including side effect functions, dependency arrays, cleanup functions, error handling, and even how to wrap useEffect in a custom hook to boost code reusability. Here we have a basic React app setup where we have the root component called app, which contains a child component named person. The person component simply displays a person's basic information like its name and email address. We also have a root level state called display to control whether to include the person component in the DOM. Initially, the display is set to be true, but if we click the button to toggle its value to false, the person component will be removed from the DOM. At the moment, we hard-code the person's information in a JavaScript object, but in real-life projects, you never hard-code data statically in front-end code. Instead, the data should be fetched from backend. To emulate a backend, we are going to use the JSON placeholder, a free online REST API that you can use whenever you need some fake data. In our example, we are going to make use of its user's API endpoint. To retrieve a single person's data instead of an array of persons, just add the user's ID at the end of the URL. Now the biggest question is where to call the backend API from the front-end code. Well, that's where the useEffect hook comes into play. We call this hook at the top of the person component and provide two arguments as its inputs. The first argument is a function. We call it the effect function. The second argument is an array, and we call it the dependency array. The effect function provided will be run in two cases. The first case is after the component's initial rendering, and it will always happen no matter what. The second case is after the component is re-rendered, and the state or props that cause the re-rendering is also in the dependency array. For example, if the component has two states, state A and state B, but only state A is included in the dependency array, then change in either state A or state B can cause the component to be re-rendered. But the effect function will only be triggered following the re-rendering caused by change in state A. We will leave the array empty for now, which means for the whole lifecycle of an instance of the component, the effect function will only be triggered once, following the initial rendering. Let's first log a message from the effect function. We also log a message from the render function. Go back to the browser and refresh the page. We see the component is first rendered, then the effect function is called. If we toggle the button, the person component will be unmounted. When we toggle it again to add it back, it will go through the initial render again, followed by the effect function. Having confirmed the effect function will always run following initial render, let's call the backend from the effect function. Go back to the browser. The data is successfully fetched from backend. But now we are merely logging the data in the browser's console. To display it in the web page, we need to make the person object a state of the component. Once we have fetched data from the backend, we shall update the state to re-render the component. And since the person state was initialized as null, an exception was thrown when the code attempted to read any properties of a null value. To solve that, we can add another state called isLoading. Initialize as true. Change it to false only after data has been retrieved from backend. In the returned JSX, add a ternary statement. When isLoading is true, display a loading message. Otherwise, display the person's information. Now let's go back to the browser and refresh the page. We can see a loading message shown for the short period after the component's initial render and before receiving data from backend. At this point, you may think everything is working correctly, but there is still one thing missing. Let's recap what happens in sequence. First, when the page is refreshed or when the toggle button is clicked, an initial render of the person component is kicked off. As a result of the initial rendering, a loading message is displayed in the browser, but also it triggers the effect function. Inside the effect function, a GET request is sent to backend. When the data from backend is ready, we call setPerson and setIsLoading functions to update the states, which will obviously trigger a re-rendering. The DOM gets updated and it now displays the person's information instead of a loading indicator. As you can see, the effect function is essentially a callback function, which means unlike lifecycle methods, effect methods don't block the UI because they run asynchronously. That raises a question. Is it possible that the component gets unmounted from the DOM before a side effect is finished? The answer is yes. To demo that, I'm going to make the latency of the side effect more noticeable by wrapping up the fetch method with a set timeout of 2 seconds. This emulates the network latency. We also log a message in the browser console to indicate that data has been received and the states are about to be changed. Now when we refresh the page, the loading message will remain in the DOM for at least 2 seconds. Then it gets replaced with the fetched data. But what if when the data is still loading, we quickly toggle the button to remove the whole component from the DOM? You can see the message still gets logged, even though the component is no longer in the DOM. I know you might argue, Grace, why are you making a fuss about it? Just let it log the message. It's not a big deal, is it? Well, unfortunately it is. Because the code is logically wrong. The side effect belongs with the person component. Hence, when the person component is unmounted from the DOM, any side effects associated with it should be gone with it. If you're still not convinced, I'll give you an example to show why this could lead to a bigger issue. Instead of hard-coding the ID of the person whose information we want to retrieve, let's parameterize the ID as another state variable. And the value of the ID could be changed by a drop-down input. Add the ID to the dependency array so that every time the ID is changed, a new GET request will be triggered to fetch the new person's information from the backend API. Now, let's go back to see how it looks in the browser UI. Initially, the ID is default 1. When we change it from 1 to 2, wait for 2 seconds, we can see the information has been changed from the first person's name and email to the second person's. But what will happen if I switch the IDs more quickly? Let's give it a go. Did you notice the quick flash that the second person's info briefly appeared before the third person's info was displayed? What happened was that we first changed the ID from 1 to 2, then quickly changed it again from 2 to 3 before 2 seconds passed. Essentially, we were saying, hey, I don't want the information of the second person anymore. Give me the information of the third person. However, because we didn't cancel the previous request to fetch the second person's info within the useEffect hook, the app would still update the state and re-render the UI when it received the second person's information from the backend, even though we no longer needed it. To solve the bug, cleanup function comes to rescue. It is an optional function that can be returned at the end of the setup function. We already know that when your component is added to the DOM, React will run your effect function. If you have provided a cleanup function, then following every re-rendering triggered by changed dependencies, React will first run the cleanup function with the old values, and then run your effect function with the new values. We can confirm it by logging messages. You can see that the cleanup for the first person was executed before the effect function for the second person. Cleanup function will also be executed following the component's removal from the DOM. Apparently, the cleanup function is the ideal place for us to cancel the residual fetch request from previous side effect before the new effect function is executed. To cancel fetch request calls, we must first create a controller. Pass the controller's signal property to the fetch request. This lets us cancel at any time using abort function on the controller, which is exactly what we are expected to do during cleanup stage. One thing to note is that when we cancel our fetch request, an exception will be thrown. To handle it better, we have to add an exception handler to our fetch request. If the error is just an abort error, this is a kind of error that we anticipated because it was caused by our calling the abort function, so we just log it in the console. We have now covered all the basics of the useEffect hook. Next, we're going to do some small tweaks to refine the code and enhance the quality. First, we need to add a branch for exceptions that are not abort error. These could be network connection issue, for example. For such unexpected errors, we can create an error state to track it. Set the error state if the error occurs. On the other hand, if we have successfully fetched data from the backend, we should clear the error. Apart from network exceptions, another type of errors is that we have received a response from the backend, but it is not a response with the data we want. For example, we could receive HTTP responses with status code 404 if the requested resources cannot be found, or status code 500 for interval server error, etc. To handle these cases, we manually throw an exception when the response status is not successful. The exception will be caught by the catch block down the road. Now, the user interface is still a little bit buggy because when we select a new person, it will still display the information of the previous person until the new person's data has been fetched from backend. A better practice is to set the loading state as true every time before initiating a fetch request. The last thing I want to do is to wrap up our useEffect hook inside a custom hook, because currently we can see that the component is really bloated with so many states and a lengthy useEffect hook. Let's create a hooks folder under source folder and create a custom hook called useData. The structure of the custom hook is kind of like a component, but instead of returning a JSX representing UI, it instead returns a JavaScript object consisting of different variables, like the person state, like the setPerson function to update the state. The same for isLoading and error states. And because we need to use React states inside the custom hook, we also need to import useState and useEffect at the top of this file. Then, let's cut everything covering the states, as well as the useEffect hook, into our useData file. So paste it here. Now we need to provide an input to our useData hook. The input is the URL from which we want to fetch the data. So instead of using the ID inside the useData hook, we need to instead use the URL. But let's keep a note of it because it will be passed to the useData hook later when we make a call of it. So let's replace every occurrence of the ID inside our useData hook with the URL input. And instead of person, we want to rename our variable to be data so that it is more generic. We also rename setPerson to setData. Okay, now we can import the useData hook into our person component. We do an object destruction here. And call the useData hook with the JSON placeholder as the URL input. Save everything and reload the page. We have an error here. Because we didn't rename person and setPerson correctly within the useData hook. Rename data to person when we do the object destruction. Okay, save it, and now we see everything works out perfectly.